Okay, so I want to give you some tools to solve equations like the following, or to find solutions to situations like the following. What are the solutions to the equation sine of x plus 7 pi over 2? Now, in this case, the x is in angle, not the x coordinate, equals negative square root 3 over 2 on the interval 0 to 2 pi. Okay, so some first things. What we need to think about is that all of this stuff inside the parentheses, I'm just going to redefine as theta, okay? Sine of theta. So really I'm thinking sine of theta is equal to negative square root 3 over 2. Sine of what angle is equal to negative square root 3 over 2, okay? And just keep in mind that theta is measured starting from the x-axis and going counterclockwise. Now with that in mind, we also need to understand what sine is. So sine and cosine are better labeled as circular functions, even though we typically use them a lot with triangles. You'll see why in a moment. They're actually derived from circular motion, cyclic things. So things where, we have a starting place, we go away from the starting place, and we come back to that starting place. And you might be able to recognize this in maybe like the tide coming in and out in an ocean. If you've seen a spring, how a spring works, like a slinky perhaps, you stretch it out and then you bring it back to where it was. And you can do that again and again and again. Okay. And we can model that with a circle because we have a starting point. And then if we follow a point moving around the circle, its value is changing. Its theta is changing as we go around the circle. But if I think about the x and y coordinates, I'm always coming back to where I started. So I go around and I come back. Go around and I come back. So this is what sine actually is. And sine is defined in this way as the distance from the y-axis to the point in question on the circle as it's traveling around. So as this point is moving around, the radius is moving with it. And then we have these two lines going down from the point to the x and y axis. And as that point changes, those lines' length change. And we kind of track as we move around the circle. Okay. Now, the distance from the y-axis is also just called the x-coordinate. Okay. If we think about, we go from the y-axis to the point. Well, if I move this down here instead, that's just the x-coordinate of that point. All right. And look, I got a triangle. So this is actually the way that sine goes from being defined as a circular function to dealing with triangles. Now, what I want to say is that then we need to relate that back to our question, right? So really thinking about what sine actually means is it's saying at what angle theta, all of this stuff on the inside, is the x-coordinate of the point negative square root 3 over 2. Well, I don't know what that is off the top of my head, so I have to throw that into a calculator, all right? And I get negative 0.866. So let me find negative 0.866 x-coordinate on my unit circle here. And as you can see, it's already drawn, but it's right about here, okay? It's more than negative 0.5. It's more than negative 0.75. It's pretty close to negative 1, right? That's the x-coordinate in question. Now, there are two places on the unit circle where that is the x-coordinate. There's one tracking up to the point, and there's one tracking down to the point. Okay, so we're going to have two values, two x's, where this argument is going to be true, where the theta is such that this is our x-coordinate, but theta is just all of this stuff. So I set them equal to each other, and that's how I'm going to find my answer. But there's one more piece of information I need. And this comes from a lot of work we did in earlier mathematics with Pythagorean theorem and learning and getting familiar with certain Pythagorean triples. These are nice numbered triangles that have a 90-degree angle, and which is what we have here. Okay, so we have this right triangle here. Now, I see that pesky square root of 3, but I know from my work with Pythagorean triples, a specific triangle that has a square root of 3 in it. And it's this triangle right here. It's a 30, 60, 90 triangle with the side lengths, the shorter side 1, the hypotenuse 2, and the longer side square root 3. Okay. Now, since the longer side is coming all the way out here, this is our smaller angle, 30 degrees. The bigger angle is 60 degrees, okay? But 30 is also pi sixth, and that's what I'll be using in this problem since we're dealing with radians, right? So, but the problem here is that I've also got this over 2. Well, that's easy enough. I'm just going to go through and divide all my lengths by 2, and I'll have what I need, or pretty close anyway, except for the negative. That was not a good 2 there. Okay. Now I have a radius or a hypotenuse of 1, which is what I want because that's my unit circle. This is length 1. Okay. And then I have this bottom long length, square root 3 over 2. Okay, now how this is related to here and how I'm going to get a negative is just imagine kind of rotating and flipping this triangle around to get it to where you need to be so that the long edge is coming from the y-axis and going to the point in question. Okay, and since it's pointing, left, we're kind of going left from the y-axis, it'll just have a negative added to it. The negative is indicating the direction we're going in our axis, right? So that means this up here is negative square root 3 over 2, right? And same thing here. There's my hypotenuse of 1. This is almost like what I need, except I need to kind of flip that triangle over and I'll get exactly here. So here's my pi over 6 inside the triangle. And here, it's actually different. The pi over 6 is here. So on this one, I'm actually going to need to do some calculations a little bit differently. But you'll see what we're going to do. Okay. All right, so I go to my next page, and you'll see that I have the equations all set up. Now, here, what I need to think about is, okay, I've got this pi 6th action, and I'm going to estimate that over here too. Just give it a quick sketch. So that's 1 pi 6th, 2 pi 6th is going to be here, 3 pi 6th is pi over 2, 4 pi 6th is about here, and so that means this angle that I'm working with here is actually 5 pi 6th. So I need to find the sine of 5 pi 6 being equal to negative square root 3 over 2. So this is the theta I'm talking about, the distance from the x-axis counterclockwise. So that's going to help me set up my argument. Theta is 5 pi over 6. And 6 pi over 6, or pi, and 7 pi over 6. So I have 2 thetas to work with, 5 pi 6 and 6 pi 6. And I can just set that up as a simple equation. This is now solving a linear equation, basically. We know how to do this at this point. The complicated part of this problem is understanding how to find and set up that missing value. Now, you can always basically just look at a unit circle, but it doesn't necessarily help, and it can get confusing if you don't understand what sine is asking for. So just always remember that sine is the x coordinate of the point as it travels around this circle, or the distance from the y-axis. That's its definition. That's how it was created. Right. And that'll help you set up the problem. And just always remember, you can basically simplify the inside of this complicated argument here as just theta. It's just some angle. Sine is defined for angles, okay, measured from the x-axis counterclockwise. So that gives me my pieces. So the inside is just theta. There's some thetas I'm looking for that give me this value as an x coordinate. So I know what I'm looking for on my unit circle. So for me, memorizing things never worked. So this is how I always did it. Although it does help to have certain, there's like 2 or 3 Pythagorean triples that really help. The 1, 1 square root 2 and the 1, 2 square root 3 triangle are the most important ones. So those are more important to memorize for me than the whole unit circle. Okay, this is more important, understanding what everything is. Now, we come over here and basically it's just setting up the equation. Like I said, the inside argument x plus 7 pi 6 was equal to theta, the theta that made it so that the x coordinate was negative square root 3 over 2. And that happened at these 2 angles. Okay? And so from there, it's just solving a one-step equation. Okay? You need to get the bottoms of the fractions the same. So I need to turn 2 into 6. I multiply by 3, but that means I need to do that on top as well. So I'm not changing any values. Do that on both of them. Then you get this result, and then you need to take away that 21 pi over 6 from this side so that you're solving for x. Okay, and these are our 2 final answers in the end. Okay, that's it.